All right. Hello and welcome everyone to this Tricentis expert session. Thank you for joining us live and welcome to those who are viewing this as a recording. Our current webinar series, the Tricentis Expert Sessions, offers sessions with our experts covering various topics from Tricentis products. Today we'll be diving into Tosca Cloud. This session will be recorded and added to our live events recordings on Tricentis Academy where it can be referenced, and we'll share the link to that page at the end of this session. We encourage everyone to ask questions throughout the session in the Q&A chat box. Questions will either be answered directly or saved for the Q&A portion at the end of the webinar. Finally, I'm honored to introduce today's subject matter expert, Chris Calissimo. He's our product manager for Tosca Cloud. Welcome, Chris, and thank you for giving us this presentation today.
Thanks, Lindsay. And yeah, welcome everyone. And I'm excited to do this expert session because API simulation represents one of the newest technologies that we've added to our stack. And so today we're going to skim the surface of what API simulation is and then go straight into the details, talking about some of the advanced functionality that the tool provides. I think it's important to set an upfront context, though, for any of you who are joining saying, wait, hold on a second. I thought you had a service virtualization tool and it was called OSV. You're absolutely right. Service virtualization was actually present in two areas of our product line. In Tosca on-prem, known as OSV, or Orchestrated Service Virtualization, and a solution that we introduced into the cloud known as API simulation. We have combined these solutions, both technically and commercially, into one solution. So the existing OSV users, when it comes time for your renewal or as a direct sale now, you can roll into some of the advanced featuring of API simulation. But you'll see during this webinar that these are one product, and you can seamlessly create services in any way that makes sense to you, either in Tosca as model-based objects or some of the configuration YAMLs that we're going to show you today in simulation. What is service virtualization? Service virtualization is technically not a testing tool. I know that's incendiary, but the idea is that it's more like a bench vise on your workbench. It's a tool that comes in when you're doing test automation to make the job easier, specifically to make environments easier, on demand, and scalable when components are unavailable, do not have the proper test data, or are undergoing version change. Simulation stands in to mock or represent APIs so that you can test anytime, anywhere. Why is this important? Because when you're doing an end-to-end process, validating, say, a lead to cache a system inside of your application, you're concerned with what happens in the blue boxes. You want to make sure that the features that you're adding meet the customer's expectation, that they can seamlessly go through the application with no problems. However, it's not as easy as that, because when you're interacting with your applications, you're often communicating with either internal or third-party systems, such as SAP, Salesforce, NetSuite, or maybe your internal APIs and data access objects. All of that is communicating over some kind of API. Now, if any of these systems do not support the current use case that you are doing inside of your application, it's difficult to be able to test end to end. And so service virtualization acts as a stand-in by emulating those APIs in those environments and allowing you to deploy them on demand so that you can test anytime, anywhere. Now, how do we do it? In a lot of cases, it's all about hijacking the network communication between your system under test and the backend dependency. And so OSV, for a really long time, was fully capable of doing this at scale. It's a very strong tool. However, we understand that things change and that this is not what your environments look like anymore. This is what your environments look like, right? And if you're chuckling, it's probably partially out of pain, right? Because the advent of microservices brought a whole bunch of new challenges to holistically understanding network topology, but also in understanding how to test something end to end, especially when event flows are no longer globally defined. We have things like reactive or choreographed environments using async protocols, such as Kafka. How do we identify and isolate a test flow in a moving system like this? And this is a big part of where the API simulation piece really bolsters the OSV capabilities. This is not a marketing webinar. This is a technical deep dive, but I like to set the upfront context so that it makes sense. Okay, this is the tool that we're looking at. This is what our advantage is. Now, I do want to point out the ABCs of service virtualization because this is important for you, the users, when setting up your center of excellence or federated practice to be able to identify use cases that are ripe for service virtualization. You get the maximum ROI out of the tool. I recommend taking a look at your Teams or your Slacks and doing keyword searches for API outage, environment instability, missing test data, things like that, because the ABCs of service virtualization are A, access. When you are missing authentication or authorization to a specific API endpoint, like Okta, for example, and it's prohibiting your use of the application in today's environment, simulate it. That gives you unfettered control over it and allows you to test anytime. Behavior, B. When you have an API, but it's not doing what you need today. For example, I'm testing PayPal and I want to start getting 404s from them. How do you get a 404? Well, you say you unplug the system. No, actually, that'll give you a 500. A 404 is actually a really hard behavior to make just happen in a system. I mean, something's there, but not exactly what you wanted. With service virtualization, you can simulate the type of behavior and do negative or defect simulation to allow your test cases to run with the environmental conditions you were expecting. C, cost. A lot of APIs have a cost associated with them, a per transaction charge, or a licensing cost associated with them, or a sandbox fee. You can near zero that using service virtualization by creating the virtual service and then no longer having that per transaction charge. And then D, data, because every problem in software tests somehow relates back to data. But how it's important in simulation is that you can generate the data that you want using whatever mechanism is appropriate for you, and then stuff it into your virtual service, and that then acts as a vehicle to get that into your environments. And I will now say that is the final bit of marketing or explanation we'll do. Let's get nerdy. So what is Tricentis simulation? It is a series of components that all work together to build virtual services. For existing customers who currently have OSV, you'll be very familiar with Tosca and OSV Monitor. Tosca and OSV Monitor work together to create model-based OSV scenarios. We've extended the functionality into API simulation, which allows you to realize those as code, which is very important because that allows you to shift left this practice into development. We've also provided a developer IDE integration, so you can start building those API mocks and contract tests as a part of your early stage feature and API development phase. This is an on-premise solution, so don't worry about hosting private data in the cloud, but it does connect to Tosca Cloud for two very important reasons. One, so that you can provision licenses for the simulation engine and allow it to be deployed anywhere without having to find its way back to a license server. And two, orchestrations. In many cases, you will have many monitors and many agents living throughout your enterprise. Tosca Cloud, as I will show you today, allows you to orchestrate the different containers and to be able to deploy and destroy simulations on them. For today's exercise, we're really going to be living heavily in the API simulation land, which is the IDE and the simulation agent local and some Tosca Cloud. But at the end of the presentation, I'm going to show you how that imports back into Tosca, and you can go back and forth between them. Remember, please feel free to ask any questions at any time, and I'll try to answer them live. Okay, first and foremost, most important question, how do I get started? One of the major advantages to API simulation is the ease of standing up a new simulation agent. I'm going to walk you through these 3 steps. We're going to go to Tosca Cloud. We're going to download one. We're going to turn it on. We're going to connect it back to Tosca Cloud, and we're going to be good to go. And so for that, I'm going to go to Tosca Cloud. As a part of your Tosca Enterprise subscription, you are entitled to Tosca Cloud. You should have received an email explaining how to access and set up your tenant. If you haven't, I would recommend working with your CSM to get that rolling. But this is Tosca Cloud. We're going to close the quick start guide for a second. And essentially, it allows you to do a lot of the functionality that you would do in Tosca. It's obviously an evolving product. The piece that we're interested in today is API simulation. And so API simulation in Tosca Cloud is made up of 3 different pieces. The API playground, which we'll talk about a little later, but is essentially a Postman-like interface for API testing. The simulation registry, which hosts a library of your virtual services, connections, contract tests, etc., so that you can view them and deploy them to your various agents. And then finally, your simulation agents and what version they're on, how they're connected, etc. To set up a new simulator agent, you either click on the Get Agent Details button, which gives you access to the download, or you go directly to this little question mark and click Downloads. The simulation agent is available on Windows, Mac, and Linux, and is available as a Docker container. We're going to be showing Docker in a little bit here. The Docker container lives inside of the Linux distro. I'm just going to set up a Windows agent today. So click the Windows agent. It's going to ask you to copy some information that'll reconnect you to Tosca Cloud. So I'll go ahead and put that onto my clipboard. And then we just wait the 30 seconds for the simulator to download. The simulator agent is a portable app. It contains everything that you need right in the simulator agent. So no need to set up registry entries. And this is what makes it possible to deploy cross-platform. So if you want to do simulation in a Linux environment and close fidelity to the app, you simply download the Linux and go through this exact same workflow. All right, the simulator is downloaded. Let's start it up. And so right now, this is living in my downloads folder, but I can easily move it whenever I want. Okay, so the simulator started up and it's provided me with a welcome screen. That's it. We're good to go. Now, I could just use this offline, create some simulations, upload examples, deploy a series of services to get started. But what I really want to do is I want to connect this back to Tosca Cloud. And so to do that, I will show the welcome screen and then click on Connect Simulator Agent. This is a one-time setup. And here I'll simply paste in what I copied from the downloads page. Let me tell you exactly what this is doing. So this is the name of my Tosca Cloud tenant. And so if I worked for, say, Amazon, it would be Amazon. If I worked for another organization, it would be whatever name was designated. I work for Tricentis, so that's the name of my tenant. And the workspace is a way to separate work inside of Tosca Cloud. By default, it goes to default. And so I'm just going to connect to default. Click the connect button. And what it'll do is it'll redirect you to Tosca Cloud to authorize. And so I'll just simply sign in. And once I've done this, I am now connected between my simulator and Tosca Cloud. And this allows me to freely go from the local agent up into the cloud, view my services, view my agents. And a lot of the experiences that we're going to do inside of the local simulator agent, you can do inside of Tosca Cloud. But that way you don't actually have to install an agent on your machine. You can use one that's centralized. Okay, let's go back to the simulator agent. I'm keeping the simulator agent in dark mode today, just so that we can tell the difference between the simulator agent and the Cloud UI. Cloud UI will be in light mode, but you can change that at your discretion. Okay, so now we have a simulator set up. Let's go back to the slides and talk about what we're doing next here. I would like to create a virtual service. Now, there is a ton of ways that you can create a virtual service through request response pairs, by importing a service definition, converting API tests into simulation. But because this is an expert session, I really want to focus on some of these more complex aspects, such as learning mode, network capture, and stateful simulation. In order to talk about that, we have to talk about our proxy modes. So whenever you want to capture an interaction between a consumer and a producer API, it really depends on where your focus is. If you are directly testing that, you'll probably want to create an API contract. But if you are testing an application that has a dependency, you'll want to create a simulation. And the best way to do that is by recording the transaction with the live system. Now, I understand if you're creating something new, you'll probably import a service definition or request response pairs. Don't worry, we'll show that at the very end. I want to get to the expert stuff. In order to record a transaction, you need to set up a connection. A connection is essentially a proxy that listens at one end and forwards to another end. Once you have a connection set up, you tell your application to talk to that connection, and that connection then forwards to the real service. The real service responds, and it goes back to your application. Now, in a lot of cases, the application will have no idea that anything has happened, nor will the real service. For all intents and purposes, they think they're talking to each other. But something very important has happened. We've actually captured the traffic as it's gone through the proxy, and we can then use that to create a virtual service. Now, we have some other modes that's available to this. And so in this particular case, we're going to talk about forward first. Now, forward first does what it sounds like. It tries to go to the real service. And if the real service doesn't have what it needs, and that's defined by something called a failover trigger. A failover trigger could be a 404, it could be a SOAP body, it could be a timeout. It's something that says this service didn't respond in the way that I expected. In that case, we would then forward to simulation, and then simulation would then respond to us. Think of this as fault tolerance. And this is typically the end result of creating your simulation for stability purposes in the environment. One of the more advanced capabilities we have is simulate first. Technically, it's just the opposite of forward first, but it's going to lead us into some really super powered capability. In simulate first, we try to go to the virtual service first. And if we have a virtual response, we will serve it up and send it back to the SUT. But if we don't have a response from simulation, then we'll go to the real service and then provide that response back to the application. Now, this is important for a couple of reasons. One, this allows you to surgically pluck specific messages off of the line. You don't have to proxy everything. You just say, hey, I'm only interested in this call and this call and this call, and those will be served by simulation. Everything else goes to the live service. It makes it easier to adopt. But there's another distinct advantage, and that is the ability to learn automatically messages over the wire. And how did I make that leap? Well, think about this flow again. The message comes in to the connection from the application, and it tries to go to simulation first. It doesn't have what it needs. It then goes to the real service. Well, that is what we need. And so what the learning engine does is it will actually capture that response on its way back to the SUT and automatically build a virtual service for you. And so that actually is the first practical example I want to show you. I want to show you learning mode. And we built it for a very specific reason, to lower the cost of generative AI. A lot of our organizations, including ourselves, are facing increasing costs from generative AI right now. And that's because a lot of the leaders have come in and said, hey, we need to build AI. We don't care what it is. We just need to have an AI story. And we say, okay, let's go. So then we start experimenting, we start implementing something. And at some point, we have something market viable. So we start regression testing it. And this is where our costs start exploding, because we're now piling up more and more requests to engines like OpenAI, who have a per transaction fee. And so in our research, we identified that most of those calls could actually be simulated, because when it comes to testing, it doesn't actually matter if we're talking to real OpenAI. What matters is what our application does with it. And so what learning mode does is it allows us to capture messages over the wire using a learning connection and then automatically build virtual services for it. I'm going to do a couple of things at once. First off, I'm just going to turn off this new simulator. And instead, what I'm going to do is I'm going to start one in my Docker engine. And so let me just pop open my Docker engine here. Move it over here to the main screen. See if this guy starts up. And then I'll just turn on a container. Okay, Docker is now running. It's given me this port 17070. I'll go ahead and copy this, and then I'll jump over here and load this guy up. And I noticed that my Docker here. Okay, so this is an empty container basically running inside of my Docker. I'm going to go ahead and upload a connection. This is one of many connections that we will provide to you as an example. This one is specifically designed for OpenAI. Now, this is the first time you're looking at a simulation file. Don't be concerned. It is YAML configuration, very similar to what you see in Azure DevOps and GitHub. There are a couple of key principles at play here, specifically the listening and forwarding modes and what we call a pattern. In this case, this pattern that we have provided knows and understands ChatGPT traffic. We can learn the patterns as a function of recording the service naturally and then creating the response and looking at what triggers were put in place. Triggers are correlation mechanisms. Now, before you freak out about the code any further, this same object, the learning mode, can be viewed as a non-coded object. And so essentially what's happening here is that a request is coming into this port. And when it goes to that port, it's going to forward itself to the real AI endpoint, which is here, OpenAI. And on its way through, it's going to do learning. It's going to watch for traffic and build virtual services for that. Now, if you want to create a new service, you can simply, or a new connection, you can simply come in here, choose the create new connection, choose which service you want it to go into, and then you'll have a connection that you can then configure with whatever message format and protocol that you want. Okay, I'm going to go to this one here, and I am now going to open my ChatGPT test. So let me jump back here. Okay, so this is like your standard OpenAI test. Basically, this one is going to ask OpenAI 3 questions. Say hello world. It's then going to say, what is the meaning of life? It's then going to ask, explain gravity. And in the explain gravity request, it's going to chunk the response. This traditionally talks to OpenAI, but right now I've told it, don't talk to OpenAI, talk to me. And so if we go back to our learning connection, we see here that this is actually communicating with this 1444 connection. Okay, I'm going to delete this piece here because I don't actually care about it. And now I am going to send a request from my engine. Now, OpenAI has been a little slow over the last couple of days, so we'll see how quickly it responds. If not, we'll kick it into gear. Essentially, what's happening right now is that the client code that I have is now creating an API call. That API call is then flowing through my proxy to the OpenAI service, and then the OpenAI service will start responding. And it looks like it's going to be a little slow for us today. We'll give it a little kick here in a second if we don't see a response come through. But this is another one of those challenges that comes with OpenAI, is that can be a little unpredictable and create a very unstable dependency in your environment. Let me give it a little kick, see if we can wake it up here a little bit. And then if not, I will let it relax for a second, put it off to the side, and we'll come back to it once we see the actual responses coming through. Essentially, what's going to happen is when those requests come through, we're going to match it against patterns. So let's talk about patterns. So patterns are basically the things that we should look for in a request. So in this case, we're looking at the path. We want to see the path. We want to see a query parameter called API version. And then we want to take apart the message for correlation criteria. I see that ChatGPT has graciously responded to us. So let's see what's happened over here. And automatically, we have 3 beautiful virtual services. Okay, what just happened? So if we go back to our slide and we pop open this learning example, We clicked go in the AI test. The AI test then went through us to OpenAI. Actually, what it tried to do was check to see if we had an OpenAI response, and we said, no, we don't. So then it went to OpenAI. That OpenAI response just came back, 3 of them specifically, and we automatically learn those in our simulator. And so each one of these represents a virtual service. Let's look at the first one. Couple of key principles here. A trigger is a wait on. This is the thing that we look for in order to determine whether we should respond to this service or another system should. In this case, if this, and this, and this, and this, in this case, we're looking for say hello world. And if we get say hello world, then we respond. And so here's our response, hello world. This is actually the whole response that came back from ChatGPT. They're pretty big. In this particular case, here's the text that we're interested in. I'm just going to change hello world to say simulated. You probably wouldn't change your responses of the virtual services because that's the actual response from the system. But for the purposes of demonstrating the simulation, I want to do so. Here's the other one. This is basically the what's the meaning of life? Not super interesting. What is super interesting is chunked responses. So this is a streaming response that's coming asynchronously from OpenAI. And so here we've collected up all those responses and we'll respond back as a text event stream. Simulation does a lot to kind of auto-interpret what messages on the wire look like so that you don't have to spend a lot of time making that system accept the message. In this case, this response is basically saying gravity is the force of super boring, right? It's basically streaming this response that we see here. Gravity is the force of attraction between 2 masses. So I'm going to say instead that gravity is the force of simulation. Just so we can see that response come through. Okay, we've made changes to our services. We've saved them. All those definitions are automatically updated if we were to then go and try to rerun our test, which I'm going to do now. And what we should see, depending upon how quickly we want to see that failed response coming from ChatGPT, is simulated responses coming back from our engine. And sure enough, here we go. Instead of hello world, we got simulated. How can I assist you today? 42 went to that second virtual service. And then here is gravity is a force of simulation between 2 masses. So a lot of pieces I explained at once here, and now's a good time to start asking some questions. So the simulation agent is, the simulation definitions are represented as code. And this is so that we can build them as a part of our early stage development mocking practice. But most of the workflows don't involve writing any code. I didn't write any code here today. I used a learning connection or a service definition importer or evolved one of my examples, or what you'll see in a later case, converted one of my API tests. But when I want to change this, I have detailed access to every part of the request and response through the code so that I can easily create simulations for the response. Okay, so let's go here. I'm going to get to my Docker engine here, and I'm actually going to close this guy off today so that this container doesn't block my usage. I'm not sure why it's not showing me the Docker UI, but that's okay. We'll go ahead and just quit it right over here. All right, fine. Docker's being annoying today. Let's go back to the deck. So we also have a network capture and creation engine. And so those same connections can be used to retrieve traffic that flows through your simulator. And you can use that traffic to then create API tests and virtual services. This is kind of your standard service virtualization usage model. The way that you would do this is that, and I'm just going to start a local simulator on Windows, get this guy going. Yes, connect to Tosca Cloud. And I'm doing this to show you something specific here in the engine. Once this guy starts up, should get our UI. Okay. Inside of the capture page of simulation, you essentially have all of the different connections that you have created, and you can capture traffic over those connections. And so a couple of connections that are kind of interesting to me. I have one here from my TriServe listener, which is just an insurance calculator that I have running on my machine. And if I were to click on this guy and enable capture, any data that I threw through my insurance calculator would show up here in the screen. Let's give that a try. I'm going to go to the insurance calculator. We'll see if this guy starts up. Oh, gotta actually start the insurance calculator up. 1 second. Start this. And then I would be able to interact with this UI, which I will do here, and go to the CRM service, which will capture traffic here over the wire. Don't worry about this UI. This is just a little demo application that we have at Tricentis. What's important is that this insurance data is actually configured to communicate through that network capture connection. So if I was to hit go here, what I should see inside of my application, if I were to go back to my UI, is that network connection information is flowing through my listener. And so from here, I can take that information and I can choose it based on filtering and any type of, specific information you want in your traffic, and then convert that into an API test or an API simulation. But to make this easier on you, one of the major challenges that we have with network capture is installing the proxies in the first place. And so our network engine in API simulation is built on an open standard known as HAR. And if you're not familiar with a HAR file, HAR files are HTTP archive files that can be obtained from things like Chrome or from AppDynamics, Dynatrace, a lot of your observability tools. We ingest an open standard and we create an open standard when we are recording our traffic. And so with that, you can actually upload traffic from any system. So here I'm just going to go and put in some Amazon traffic that I recorded. And what we will do is consume that HAR file just as if we had recorded the traffic ourselves, which is really nice because then from an ROI perspective, you can easily create, a virtual service that's important to you. Here, I'm just going to filter down to JSON. Let me see if it's still navigating this, JSON. Okay, here's some JSON calls that were made as I was shopping. And I'll just select these guys and create a virtual service or an API test from them. Here, I'm actually just going to create an API test because we're going to talk about contract testing in a second. Amazon API test. I know I did it too early. Doesn't really matter. Okay. Now I have an API test called Amazon API test, which is essentially taken that traffic that I recorded over the wire and made a little contract test for me to execute. I did this very deliberately because I wanted to highlight another screen that will be very powerful for you to use as a part of your tools usage, and that is Play. So think of Play as a Postman-style interface that's designed for interacting with your virtual services and your natural APIs. In this case, here are the different calls that were made from my Amazon HAR traffic. I actually haven't run these in a second, so let's see if Amazon still lets me. Yes, it does. And you could use these to invoke traffic over the wire or to directly validate that a virtual service is functioning the way that you expect it to. And the contract tests themselves are written as code. And a key differentiation between a contract test and a virtual service is this element called direction. This is one of the most important principles in API simulation. Which direction is my call going, in or out? In the case where I have a virtual service, and so here I'm just going to look at this virtual service, all of my requests should start with in and then go out. But in the case where I'm making an API test, the request should start with out and go in. And the good news is you can intermix these in any way that you want to create a stateful scenario. Let me check real quick to see if we have any questions in our Q&A. Is it possible to use something like Swagger to generate anything like this? Well, I thought I was going to be able to get away from the basic stuff and focus on the more complex stuff today, but I do think it's probably important to show you how to consume a WSDL, a Swagger, a schema, what have you in this tool. So here I'm just going to grab a service definition. I'm going to grab the actual service definition. And right here inside of my simulator, one of my options is to import from service definition. You can put a Swagger OpenAPI definition like I'm doing here, but you could also put a WSDL as well as a schema if you just have the schema. And if I were to say go, then I would create a pet store. And so here's my pet store with all the different services. So yes, absolutely, you can ingest a service definition. I like traffic gathering, or at least starting with traffic gathering so that you can identify the actual services that are in play. And yes, of course, if you're creating a net new service, then that traffic gathering option isn't necessarily available to you. And so using a pet store and then extending it is a really good way to go. I hope that answered that question for you. Oh, here we have another question. Is Tosca Cloud available only in Tosca 2024.1 and onwards? No, Tosca Cloud has actually been out for a couple of years now. I think it's smart, though, to use 2024.1, especially in the context of API simulation, because as I show you towards the end of this presentation, the import and export from Tosca, you're going to want 2024.1 so that the features are in sync. But Tosca Cloud it's not a strict requirement for 2024.1. Okay. I'm going to start deleting some stuff just to clean up my workspace here. And I want to move on to our next topic. And that is shared state. So one of the things you're going to hit pretty quickly in any service virtualization initiative is how to create a service that stores persistent data. For example, if I add a cart, update a cart, delete a cart, get a cart, those CRUD operations, I really want them to actually happen. I don't want to say add item to cart and then I go and I retrieve my cart and it's empty. There are use cases for that. Especially in performance testing, where you just kind of want things to be very static and not build up these big complex data structures. But in most cases, you need stateful virtualization. API simulation tracks state internally through a state engine. And I'd like to show you how to use that today. I have a couple of tests to highlight this. Specifically, I have created a contract test, which we've talked about. And the contract test has a couple of different steps. Create a shopping cart, update the item in the shopping cart, get the cart, and delete the cart. I also have a virtual service that is operating on all those actions. So here's my service for creating a cart, updating the item in the cart, getting the details of the shopping cart, and then deleting the shopping cart. The first thing that I want to bring your attention to is the resource. So these three lines essentially tell me, hey, this is going to be a stateful service. And I need the data to be stored and retrieved from, we have a couple of different options here, a table, a file, an in-memory key value, or you can even connect to a database if you want. In this case, I'm just using a CSV file because it's easy to view. Okay, that gives me a resource that I can interact with. And actually, that CSV file is here, but you don't see it because we're currently filtering. So I'm going to go ahead and unfilter, and here's my CSV file. So you can see my data is empty. Now, let's use this. So I'm going to go to my simple state service, and we're just going to do the first one, which is create a cart. What's going to happen is that a request is going to come. I'm going to trigger, which is the correlation criteria on cart create and that it's a post. I'm going to grab the cart ID, and then which I'm going to randomly generate, and then I'm going to provide a response. And the most important piece here is I'm going to store that in state. Don't worry, this example will be provided to you. So let's do it. I'm going to use my test in play to go to my shared state and say, all right, let's create a cart. Play. Cart created. And it says I have a cart, 22722. Well, let's do something. Let's go back to, and I'm just going to duplicate this tab. Let's go back to the inventory, and let's go ahead and look at that CSV file, shared state CSV file. And sure enough, there is a cart there. So what's happened is that we have taken the data from the incoming request, and we've copied and pasted it into what we call a buffer. That buffer is then stored inside of this persistent state resource. I know that was a lot of complex language, but the idea is I can then use that as a key to then assign new values and retrieve data from. So let's do the rest of the use case here. And actually, I'm just going to move this over here just so we can kind of see this state object updating in real time. This on one side, put this on the other. Okay. What do I want to do next? Let's update the cart. And so in this case, I want to update a cart. And so I'm going to take my cart ID that I just generated, and I'm going to change that so that it's updating this cart. And I'm going to say that the item description is this is a new item. And if I were to hit play and then come over here, I see, oh, look, I have a new item in my state. And if I was to update it again and say new, it would update that specific item. Oops, I didn't hit save. It's new, and then run. Need to come back to the original. I think it's because they have these two side by side. Now, what's the next thing that I might want to do? I might want to get the cart details. So in this case, I'm going to provide the cart ID. And this should retrieve the details of my cart. And this would be your standard retrieve. And then if I wanted to, I could then delete. But before I do that, I want to have some fun with this and kind of show how multi-user state works. So let's go back to cart create. And in this case, I'm just going to create 1, 2, 3, 4 more carts. And then if I come here, I see that I actually have all these carts. Now let's say that I wanted to update one in the middle. Each one of these entries is a unique item, and it allows for multi-user access for those items. And so if I wanted to say update, for example, and update just that middle item and say, this is the middle item, and then run and look at my state again, I'm updating that item. Very technical detail, extremely powerful feature, because that allows you to enable multiple users to track different state on different items so that one user won't conflict with another user. And it just allows you to scale this statefully in containers ephemerally as a part of your CI/CD pipeline. And so removing an SAP type service that has a stateful behavior set to it is as easy as creating one of these services. All right, let's delete. So I'm going to come in here and I'm going to delete, I don't know, let's delete this one. And so I'll just come into this particular service, hit delete. And now if I call this up, that one's gone. And so through this combination of CRUD actions and shared state resources, you can easily create services that are living entities that update their data sets based on patterns of behavior. And you can even load those data sets into the service from the beginning so that you can have a full data set on your service without having to record that traffic. Okay. Look real quick to see if we have any questions. It doesn't seem like we have any. Let's go ahead and talk about data driving. So I think I already talked about this shared state simulation, but I wanted to provide a graphic to kind of explain the use case for it. In this particular case, this is one of our customers that was basically creating order forms, and the order form engine would sometimes go offline in their environment. And so what they did was they created a virtual representation of the order form. I went through this too fast. This was a combination of the failover trigger and shared state. So they went to go check to see if the order form was available. It was not. So they failed over to a virtual service that then went and created an order. In this case, it stored it persistently in their SAP data store. Then when subsequent calls came in and said, all right, I'd like to update the cart, or I'd like to update the order, it also retrieved that ID, and same thing with shipping. And all of those were basically stored in the shared state engine. So these concepts of forward first, simulate first, and shared state can be used interchangeably to create exactly the service behavior that you want with minimal effort. Yes, it takes a little bit of understanding, but a lot of these keys all trigger off of 2 or 3 different properties: direction, trigger, and resource. And as always, we're going to be conducting these sessions more and more. But I want to talk specifically about data driving. I have a service here where I want to get a response about a magic user. It's a little Harry Potter virtual service I've created. I imagine that in the world of Harry Potter, they probably have SAP, right? How would they track all the witches and wizards that are currently attending Hogwarts? Sorry for getting nerdy there, but maybe each entity has an ID associated with it. For example, here's Harry Potter, ID 1. And if I were to request another ID, 45, for example, this would give me Anthony Goldstein. Never heard of him. He's Ravenclaw, apparently. How many witches and wizards do you think exist in Harry Potter? I'll tell you the answer. It's 163. And so creating a virtual service with 163 different responses would just be a nightmare. And so we can data drive the virtual services, both the correlation triggers and the response objects that come out. It uses the same concept that we've already talked about, a resource. So in this case, I have a resource, and that resource is a file called Harry Potter CSV. Let's look at Harry Potter CSV. Wow. Okay. Lot of data here. And you'll see actually in some cases, some of these fields don't actually have values associated with them. And so we can dynamically include and exclude values based on the existence of that data. Okay, so how do we use it? Well, once we've defined a resource, we can then come in and say that if a request comes in, then I want to trigger on a specific value, in this case, the existence of a path. And then I want to buffer the ID and then use that for a data lookup. This syntax is almost identical to the syntax you will see in Tosca. In this particular case, what we're saying is that when populating a name, get that name from the Harry Potter resource where the ID equals the incoming ID. And you can do all sorts of crazy things with this. It supports regular expression as well. You can combine values together and dynamically construct exactly the response that you want. In this case, it's just going to do a data lookup in the file, and it's going to fill in all the values, and then it's going to override those values in this payload. And the net effect is that if I were to come into here and say, let's get 155, for example, okay, that gives us, for some reason, Harry Potter again, which must be 155. Okay? Now, there's an interesting thing that happens here, because at some point we're going to run out of run out of users. And so I think I put a catch-all in this. But if at any point you ever do something that equals a value that doesn't actually exist, we provide you a polite message to help you understand what was tried. So in this case, it says match for echo failed, instead received this connection. And if I were to then come down to the specific magic user that I have, which we ultimately try to put last, it'll say that I expected this path, instead I got this path. It's our best attempt to try to help you understand why services don't correlate, so that as a part of the debugging process, you can come back in and try to figure out the sequence of events. All of this information bubbles into the logs. The logs provide details to help you understand the sequence of events that took place as you were interacting with a service. I'm going to reset my size here on my screen. You can filter down to just messages, as well as providing multi-level filters to get down to exactly the message that you're looking for. You can then download those for your own viewing or for sending to our support team. But each message will contain the top-level information about the connection, the simulation, the service, the step and trigger, and then any information that was observed within that request and response. Just in an effort to try to make things easier to understand. Okay, we're coming up towards the end here, and I want to show you a very important feature. Some of you may be sitting here going, what is going on? This is so technical, right? It can be a bit intimidating at first, but the goal is that we want to be able to interact with our services in our development team. So we can shift a portion of this left into the development practice. I'm going to open this same workspace inside of my IDE. And so what I'm looking at now in Visual Studio is the same definition that I have stored in my Git repository. And so if I was, for example, to come to this sorting connection, okay, it says some things. If I was to just get rid of this screen and just live in my IDE, I have IDE integration. And so if I was to come here and say, I changed this, save, and then come back into my desktop, I would notice that it updates in my desktop. So you can seamlessly go back and forth between our UI and your IDE UI. And all of these things can be stored in source control, which I actually have connected on both sides. And so as you make changes to services, I'm just going to open up GitHub here. It'll show you everything, all the changes that you've made. And then you can easily merge and branch and do all the things that you would expect to do with test artifacts to make sure they're up to date. Okay. We're coming towards the end here. If you have any questions, go ahead and throw them in. I would like to address one last thing, and that is importing into Tosca. So right now, we've sort of been living on the developer side of this whole equation. And as I indicated earlier, this solution allows you to traverse from developer to QA tester and back and forth. So what does that experience look like? So I've started in developer today, but you could start this same experience as a QA tester in Tosca. So for that effect, I'm now going to open Tosca. And this would be where you were living if you were building test automation or API test automation, UI test automation. There's a couple of things that you need to do to your Tosca in order for this to all work, but I'll show you them in just a second here once it loads. Do you notice that new fast loading time we have in 2024.1? Pretty cool feature the team did. You need to come into your options and you need to ensure that your OSV add-on is enabled, which it should be. And then you have these two features, file export to OSV scenario and file import from simulation file. Turn those two guys on. Once you've done that, what you can do is you can take any service that you've developed as code and import it into Tosca as a modular object. Let's do this one. So I am going to go OSV and I'm going to say right click OSV import from simulation. Then it says, tell me where that is. And I'm just going to go into my workspace and I'm going to go into Data Magic and grab this one. It'll tell you whether things are okay or not. It's ignoring the contract test because Tosca doesn't do contract testing, but that's okay. And when I say okay, and we look in Tosca, now we have a module-based object that to anybody that's familiar with Tosca should look pretty familiar. These are basically module attributes that are connecting to the element locators inside of the test. And so if I were to then go into the scenario itself and do a little bit of expansion here, I would see that it's waiting on magic and it's buffering this particular resource, which we already knew from looking at the code. Then we see our different inserts that are taking place. And then if we were to go into the technical view for this response, which I'm just going to go over here, we would see our response object. Any changes that you make in here to the modules can update the scenarios and all that same beautiful model-based flow that you get in Tosca. Once you're done with that, you could then simply say OSV, export to file. I'm just going to throw it on my desktop. And if we were to go back here, we would see that this same artifact that was just in Tosca can be exported into a simulation file. Obviously, there's a tiny bit of entropy between features that are supported in simulation and not, but then that seamlessly allows you to go back and forth between developer and tester. Okay. There's a lot more to discuss here, but I think we're coming towards the end of the expert session. This is our last chance to ask any questions. Here we go. Is there any downsides to using Tosca Commander for API versus API in the cloud? I don't think so. So the question specifically is, I feel, is there any disadvantage to using API simulation in Tosca versus using API simulation in the cloud? And I don't think so. It's about what do you want to see? Are you comfortable with code? And some people just love code and they don't want to tangle around with messy UIs. In that case, you can use the YAML configuration. Other people want to deal only with modules and never see a drop of code. In that case, you can work with Tosca. It doesn't really matter. You can freely go back and forth between them. There are some features that API simulation extends on top of OSV. And so for that, you would want to deploy into the simulator agent, but it doesn't prohibit you from bringing those back into Tosca and manipulating the messages. I hope I answered that question. Okay. Couple of resources here. If you're interested in what you see and want to try out Tosca Cloud and API simulation, you can scan this QR code. Within Tosca Cloud, we have the entire breadth of what I just showed you available as a getting started guide. So if you weren't paying attention to anything I just said, get access to Tosca Cloud and you can go through the API simulation experience yourself, which is basically an expansion of what we just did, as well as gaining access to your simulator and playing with that. One thing I would like to point out is that we do have a design and partner program. This is a newish technology, and I would be very interested in getting together with anybody who is interested in what they see but has any particular feedback. We're always trying to grow and learn. We love our customers, and your feedback is vital to our success. Scan this QR code, connect with me, tell me your thoughts, any recommendations you may have. And with that, I think we're good. No more questions. We'll go ahead and close out. Thank you, everybody, for your time. I hope you found this session valuable, and I look forward to seeing you in future testing sessions. Bye, everybody.
Awesome. Thanks, Chris. Thanks, everybody. Have a great rest of your day.